All right, tonight's episode of Python Papi, we're back inside our Tensorflow course. As I informed you earlier, because we did our generative AI course earlier, we're doing our Tensorflow now. And tonight we didn't do anything spectacular. We didn't do any code writing. We basically watched a bunch of demos and did some note taking. So let's pick up where we left off from last night. And tonight we went over, and I don't know if we went over the inverted residual blocks yesterday, but basically we touched on that before we moved on to a new topic. Before we move on to a new topic, I'm just gonna lightly go over what we went over with the inverted residual blocks. Now, first let's start with the residual blocks. With the residual blocks, what we're gonna have is we're gonna have data that starts off as big, and then in our middle layers is gonna get compressed into small, and then the outputs are gonna be big also. So that's going to be the residual blocks. Now, the inverted residual blocks, of course, is going to be exact opposite. With the inverted residual blocks, the topic we're talking about now, our data is going to start off small. Then in our middle layers, is going to get bigger or expanded. And then on the output, it's going to be small again. So that's basically what the inverted residual block is. It's basically an opposite of the residual blocks. And that's basically what we went over with that. The topic we touched on tonight was going to be depth-wise convolutions. So let's pick up some light reading for that. So now, in addition to the fact that we're using depth-wise convolutions instead of the normal convolutions, the fact that we have a relatively lower dimension of data going into the smaller blocks because we're using an inverted. So it starts off small, then gets big, then gets small again. So yeah, we have a relatively lower dimension of data going into the smaller blocks and coming out of the smaller blocks as the input and output means that we can transport very low dimensional data throughout our mobile network. So we have a low dimensional data going in, low dimensional data coming out. And then inside we have an expansion, like I explained. This expansion layer permits us to capture as much information as possible from our input features. Now, basically, that's what we went over tonight. We just dived into some more aspects of the depth-wise convolutions. And yeah, like I said, we didn't do anything spectacular. We just saw a couple of demos and did some note taking. But of course, I will keep you posted every step of the way as we move forward. For now, this is the Python Poppy. You guys stay Gucci.